So now let's look at finding minimum values by first completing the square, and it gives you some idea of the usefulness of completing the square. Okay, so example 1. Let's find the minimum value of the equation y equals x squared plus 6x plus 5. So we've got a quadratic trinomial here, and we're asked to find the value of x where this occurs. We're trying to find the minimum value of y at what point of x this occurs. Now the way we do this is, of course, completing the square. So let's complete the square here. We've got x squared plus 6x plus 5. Now if we want to complete the square, let's halve the 6. So 6 divided by 2 is 3. But also we know that 3 squared is 9, but we want not 9 but 5. So we have to subtract 4 from that. So x plus 3 squared minus 4 is what the equation is. So we've got y equals x plus 3 all squared minus 4, and we want to find the minimum value of this. So let's have a look at the brackets term. Now the brackets is all squared, and we know that a square has to be greater or equal than 0, because a negative number squared gives a positive number, and you can have 0 squared, which is 0. So all square numbers have to be greater than or equal to 0. So the trick here is to find out what value of x would make this whole bracket term equal to 0. Okay, so what we want is to find out x plus 3 equals 0, and that must mean that minus 3 plus 3 would be 0, because minus 3 plus 3 is 0. So x is minus 3. So the minimum value occurs when x is minus 3. But what is that minimum value? Well, let's substitute. So we've got 0 squared minus 4, and we can see from this that the minimum value is just minus 4. So y equals minus 4. Therefore, we can say that the minimum value is y equals minus 4 when x is minus 3. Now, we're going to be coming to this in more detail in the next section for quadratic functions. But if you were to plot this function on a graph, on a Cartesian coordinate plane, you would get a curve like this. And we can see there that this point here occurs at when x is minus 3, y equals minus 4. So let's have another example. Find the minimum value of the equation y equals x squared plus 10x minus 6, and find the value of x where this occurs. So we're going to complete the square. What is the square of this? The completing of the square would be, so first of all, we're going to halve the 10. 10 divided by 2 is 5. So how are we going to do this? It's going to be x plus 5 squared in this. This would give us 25, so plus 25, but we want minus 6. So we're going to have to subtract 31 from that. So x plus 5 squared minus 31 is the function in the completing the square form. And now what we want to do, again, we want to find out where the brackets equal 0, because remember, a square can only be greater than or equal to 0. So what value of x would make that 0? It would be minus 5. And so we can put this minus 5 into the equation, and we can see that the minimum value would be y equals minus 31. Therefore, we can say that the minimum value is y equals minus 31 when x is equal to minus 5. And again, if we were to plot this, we would see that the minimum value here would occur when x is minus 5. So at a quick glance, if we are given, or when we complete the square for a given function or a given equation, and we complete it in the square and we have it in the form x plus p all squared plus q, then we can say that the minimum value will be q when x is equal to the the minus of p. Just like in the previous examples. And we can say that the coordinates would be minus p and q. So this is just a quick way of doing this. When you get comfortable with this, you can just look at these and you'll be able to say, okay, the minimum value of this function will be this when x is equal to the minus of this. And again, as I said before, we'll be coming to this in more detail in the next section for relationships and quadratic functions, where we'll be using this to analyse quadratic functions. Okay, thank you.